This is video 2 of 5 video series. Please make sure to watch previous video of the series if you haven't done so already. In this video, we'll dive deeper into data modeling and relationships within Power BI Desktop. Understanding how to structure your data and create relationships between different tables is crucial for accurate analysis and insightful visualizations. First, we'll introduce data modeling and the significance of relationships. Then, we'll demonstrate how to create relationships between tables. Following that, we'll explore the power of calculated columns and measures in your analysis. Lastly, we'll apply all these concepts to a real-world scenario where we'll analyze sales performance by region and product category. Let's harness the power of relationships. Before we begin, let's understand the importance of data modeling in Power BI Desktop. Data modeling involves organizing and structuring your data in a way that enables efficient analysis. It helps create meaningful connections between tables and ensures accurate results when querying and visualizing data. With proper data modeling, you can unlock the full potential of Power BI Desktop and perform advanced calculations and analysis on your data. In Power BI Desktop, it's common to work with data that spans multiple tables. For this example, we'll import data from Excel file and choose Customers, Orders, and Products tables. Please see video 1 on how to import data. You will be able to see imported data under Data View on Power BI Canvas. Once the tables are loaded, navigate to the Data View by clicking on the Data icon in the left-hand pane. In the Data View, we can see the tables namely Customers, Orders, and Products. Please note that primary field names are different among tables. Note Cust hashtag in Customers table and Customer ID in Orders table. Also, Prod hashtagged in Products table and Product ID in Orders table. Our goal is to create relationships between these tables based on the common fields. Relationships allow you to connect related data across tables, enabling you to analyze and visualize data from multiple sources. We'll create relationships based on the Cust hashtag field in the Customers table and the Customer ID field in the Orders table. To create a relationship, click on Model View from left pane. Select Customers table, and then click and drag the Cust hashtag field to the Customer ID field in the Orders table. Once the relationship is established, you'll see a line connecting the two tables, indicating the relationship. Next, we need to define the relationship type. Click on the relationship line to open the Manage Relationships window. In the Manage Relationships window, you'll see the two tables involved in the relationship and the fields used for the relationship. By default, Power BI detects the correct relationship type, which is a one-to-one relationship in this case. If Power BI doesn't detect the correct relationship type, you can manually change it using the drop-down menus. However, for most scenarios, Power BI will accurately detect the relationship type. After verifying the relationship type, close the Manage Relationships window to return to the model view. For comprehensive analysis, let's create relationships between Orders table and Products table. Similar to before, click and drag the Product ID field from the Orders table to the Prod hashtag field in the Products table to create the relationship. Once the relationship is created, you'll see another line connecting the Orders and Products tables. Again, check the relationship type in the Manage Relationships window. If you look at the data in Orders table, there exists one record corresponding to each customer and each product. Hence, Power BI has detected one-to-one relationship between tables. After confirming the relationship type, close the Manage Relationships window to return to the model view. In this case, column names which we use to create relationship are different. Therefore, Power BI didn't detect relationship among tables as soon as we loaded data from Excel. In most scenarios, it is common that primary field names among used in different tables are same. So, if you are loading tables having same primary field names, then Power BI will detect relationship on its own as soon as we load tables. Try loading data having same primary field names across tables and then Power BI will automatically create relationships among tables. Power BI detects relationship based on data in primary fields of both tables. There you have it. We've successfully created relationships between our tables, connecting data from the Customers, Orders, and Products tables. With these relationships in place, we can now perform cross-table queries and create more meaningful visualizations. Now, let's explore the power of calculated columns and measures in Power BI. These advanced techniques allow us to perform complex calculations and derive meaningful insights from our data. Let's dive in and see how to utilize calculated columns and measures. For this segment, we will use different dataset. Open Power BI Desktop and import data from Excel file. Choose Sales and Product tables. Once data is loaded, navigate to Data View and note Product ID column in both tables. Now, click on Model View and see how Power BI created relationship automatically, based on Product ID column. Calculated columns are used when we need to derive new data based on existing data in a table. For example, let's create a calculated column that calculates the total revenue for each product in the Sales table. To add a calculated column, select the Sales table under Data in the right pane. Click on Report View, go to the Model tab, and click on New Column. Now, let's write the calculation. In this case, we want to multiply the quantity and unit price columns to get the total revenue. The formula will be total revenue equals quantity asterisk unit price. After writing the formula, press Enter to apply the calculated column. You'll see the total revenue column added to the sales table with the calculated values. Measures, on the other hand, are used for aggregations and calculations across multiple rows or tables. Let's create a measure to calculate the total revenue for the entire sales table. To add a measure, click on the New Measure icon in the Home tab. Now, let's write the measure calculation. We want to sum up the total revenue column we calculated earlier. The formula will be total revenue measure equals sum sales total revenue. After writing the formula, press Enter to apply the measure. You'll see the total revenue measure added to the sales table. Now, let's use this measure in a visualization. Create a clustered column chart, drag the category column from the product table to the x-axis field and drag the total revenue measure to the y-axis field. You can customize the chart title, colors, and other aspects using the format options in the Visualizations pane. There you have it. Our bar chart shows the total revenue for each product category, using the measure we created. Calculated columns and measures open up a world of possibilities for data analysis. You can perform more complex calculations, apply time intelligence functions, and even create KPIs for better decision-making. In this segment, we'll tackle a real-world scenario by analyzing sales performance using the data we have imported and transformed. Let's dive into this practical example and see how Power BI can help us gain valuable insights. Let's start by opening Power BI Desktop and loading the data. To save time, we have already imported Excel file and loaded data for Sales, Products, and Customers table. We also added column, Total Revenue, and measure, Total Revenue Measure, to Sales table. Let's review each table by navigating to Data Model View. In this real-world scenario, we want to analyze the sales performance of different product categories. We'll focus on key performance indicators, KPIs, such as total revenue, quantity sold, and average unit price. Now, let's add visualizations to analyze sales performance. If you want to learn more about visualizations, please watch video 1 of this series. First, let's create a sales revenue card to display the total revenue across all categories. Drag the total revenue measure we created earlier to the canvas and choose the card visualization from the Visualizations pane. Customize the card visualization by adjusting the title, font size, and colors to make it visually appealing. Next, let's create a quantity sold card to display the total quantity of products sold. Drag the quantity column from the sales table to the canvas and choose the card visualization. Customize the card visualization to display the total quantity sold clearly. Finally, let's create an average unit price card to show the average price of products sold. Create a new measure called average unit price by dividing the total revenue measure by the sum of quantity column. Drag the average unit price measure to the canvas and choose the card visualization. Customize the card visualization to display the average unit price clearly. Now, we have 3 cards displaying essential KPIs, total revenue, quantity sold, and average unit price. Add slicer and drag category from products table. Using slicers we can look at revenue, quantity and average unit price per category. This real-world analysis helps us understand sales performance at a glance. Let's dig deeper into our analysis by creating a bar chart that shows the sales revenue by product category. Choose the clustered column chart from the Visualizations pane. Drag the category column from the Products table to X-axis and the Total Revenue column from Sales table to Y-axis. Customize the bar chart's title, colors, and labels to make it more visually appealing. Our bar chart now shows the sales revenue for each product category, providing valuable insights into which categories are driving the most revenue. Also, create a donut chart that shows quantity sold by product category. Choose Donut Chart from the Visualizations pane. Now, create a donut chart that shows quantity sold by product category. Customize chart by adding title and changing colors to make it visually appealing. Using Slicer, you can view report for each category. Now that all elements for our report are ready, you can adjust them to change look of your report. In this real-world scenario, we've successfully analyzed sales performance using calculated columns, measures, and visualizations. Power BI's capabilities empower us to make data-driven decisions with ease. Congratulations! You've learned the essentials of data modeling and relationships in Power BI Desktop. By properly structuring your data and establishing relationships, you can perform advanced analysis and create insightful visualizations. In the next video, we'll explore creating interactive visualizations. Don't forget to like, comment, share, and subscribe our channel No Nuggets. See you in the next video.